All right, today we are going to be working with systems of inequalities. Systems of inequalities. We're going to solve a system by graphing. Solving a system by graphing. So what you're going to get today is, last week you worked with systems of equations dealing with lines, and you found out where the lines intersected. Today and tomorrow, we're going to be working with these systems of inequalities, and we've got something like 2x minus y greater than or equal to -3. And then we got y is greater than or equal to -1/2 x plus 1. Now, the first step is going to be to get both inequalities in slope-intercept form. This bottom equation is in slope-intercept form, but this top one isn't. And this is a y right here. That's a y. 2x minus y greater than or equal to -3. This top inequality is not in slope-intercept form, so I'm going to rewrite it. 2x minus y greater than or equal to -3. Gonna subtract 2x from each side. And when I subtract the 2x, I'm going to put the -2x next to the inequality because I'm looking for slope-intercept form. And when we're dealing with slope-intercept form, this y has to be positive, so now I divide everything by -1. And I get y is greater than or equal to. Yep, got to change the inequality. So we're going to go here. And this is 2x plus 3. So we got two equations. We got equation number 1 and equation number 2. Now what we got to do is graph them. So to graph these, let's see, this first equation, I got a y-intercept of 1. So my coordinate plane, here's my y-axis and my x-axis. I got a y-intercept of +1 and a slope of -1/2. So I'm going to rise 1 and I'm going to run 2 to the left. And then I'm going to rise 1 and I'm going to run 1, 2 to the left. So there's 3 points that are on the line. Now, this line, since this symbol is greater than or equal to, that makes it a solid line. All right? Greater than or equal to, or less than or equal to. Those are solid lines when you draw the line. All right? So I'm going to try to get a line through here now. And we got one going up this way. So there's line 1. Now we're going to graph line 2. Or before we graph line 2, let's look at this first line again. Line 1, this is y is greater than or equal to -1/2 x plus 1. Since this is greater than or equal to, we just said it's a solid line. Now, we have to shade one side of this line or the other side. All right? And when you shade inequalities, you shade the top of the line if y is greater than. You shade the bottom region of the line if y is less than. So in this case, we're going to shade this top region right up here. This blue means we're shading everything up here. All the solutions to this system lie above line number 1. Then we're going to graph line number 2. Line number 2 hits the y-axis at +3. So we go 1, 2, 3, and we put a point on the y-axis. That line has a slope of +2, or +2/1. So we're going to rise 2 and run 1 to the right, and then rise 2 again and run 1 to the right. Now, this is less than or equal to, so it's a solid line as well. So this line looks something like this. Now, this is less than, so we're going to shade the bottom of the line, meaning everything down here. So you see it? We're shading the bottom of the line. Now, do you see where the shading intersects each other? Where the shading intersects, where the blue and the green overlap, are where all the solutions lie to this system. So everything in here, everything in on the line to their point of intersection, every point on both lines, and any point in this region. Yes. If this symbol in slope-intercept form is greater than, you shade the top. If this symbol is less than when it's in slope-intercept form, you shade the bottom of the line. And where the two shadings intersect is where the solution is. It probably would have been better to not even use that third color. See where the lines, see where the shading crisscrosses? Where the shading crisscrosses are all the solutions. Yes? Well, because the number 2 itself is the same as 2/1. And since slope is rise over run, I thought it would be easier for everybody to see that I'm going to rise 2 and I still have to run 1. That make any sense to y'all? All right, let's do one more. Let's solve this one by graphing. We got x plus 2y less than or equal to 4. Let's do y greater than negative x minus 1. All right, if I number these again, equation 1, equation 2. Equation 2 is in slope-intercept form, isn't it? So nothing needs to be done to it. Equation number 1 needs some work. So I'm going to rewrite it, x plus 2y less than or equal to 4. Subtract x from each side. So 2y is less than or equal to negative x plus 4. And then I'm going to divide everything by 2. So y is less than or equal to negative. Look, this negative x, there's a 1 in front of that x, but it doesn't get written. So this is negative 1/2 x plus 4 divided by 2 is 2. So now we've got our two inequalities. So coordinate plane X and Y. I'm going to graph equation number 2 up here first. It hits the y-axis at -1, and it has a slope of -1. So we're going to rise 1 and then run 1 to the left. Rise 1, 1 to the left, 1, 1. All right, see it? So let's see. Now, you see how this symbol is just greater than, and it's not greater than or equal to? That makes it a dashed line. So it makes it this right here. This is hard for me to draw. That's hard for me to draw. It's not a solid line. Makes it a dashed line because it's not or equal to. That means the solutions don't lie on the line. In this case, the solutions lie above the line. The line is not included. So take this and we're going to shade the top. That's our line number 2. Our line number 1, this equation, hits the y-axis at +2. It's got a slope of -1/2. So I'm going to rise 1 and I'm going to run 2 to the left. And then I'm rising 1 and running 1, 2 to the left again. That line goes right through here. It is less than or equal to. So that the or equal to made it a solid line. And look, we're going to be shading the bottom of that line. So the bottom of that line is everything down here. And you can see the region where everything starts intersecting. Or I hope that you can. Right in there. In between the two lines is where the shading overlaps. Y'all see that? Right in here. Here's your area where the shading overlaps. Anything in this yellow. There's where all the solutions lie. Everybody okay with that? All right. The only thing we haven't talked about is let's look at this for a second. Let's look at something like straight up x is, let's say that x is less than 3 and y is greater than, I don't know, 2. I'll number the equations again. Here's equation 1, here's equation number 2. Here's what these graphs look like. First of all, are they dashed lines or solid lines? They're both dashed. So watch. X less than 3. You go to 3 on the x-axis and you put a point. That's a vertical line right here. Vertical dashed line right through 3 on the x-axis. Here's your line 1. In this case, it's less than. Less than shades the left. So we shade the left of this line. Y is greater than 2. So we go to 2 on the y-axis. And again, it's another dashed line. There's our line number 2. And this is greater than, so we're shading the top. Everything up here gets shaded. And then your solutions lie where the shading intersects. So this whole area right here, here's all your solutions. Anything in this region, any point in this region would be a solution to both equations. Y'all go with that? Yes, sir. Correct. Yes. And then, yeah, and then top for greater than, bottom for less than. Now, the kind of the key to your graphs is going to be how neat you can draw them. Obviously, if you have graph paper, that would be really nice, but a lot of you don't have graph paper. So what I'm going to try to show you here, let me give you your assignment first. Let me give you this page 153, 11 through 19. All right, and then I'm going to have to scan that and get it up here for you, and then I'll show you what I wanted to show you. Yes. Yeah, because look, if you think about it, this line number 2, right? Greater than 2. Well, what's greater? You know, you got 3 is greater than 2, and 4 is greater than 2, and 5's, right? All those numbers are greater than 2, so you graph that area. Over here, you know, this was at 3, and everything that's less than 3 is what you're graphing. All right. All right, so give me 1 second to